I'm Anil Kumar sharing with you a test question on application of derivatives. The question here is the vertex of a right circular cone and a circular edge of its base lie on the surface of a sphere. The sphere has a radius of 5 centimeters. Find the dimensions of cone of maximum volume that can be fitted into the sphere. So you can always pause the video, answer the question, and then look into my suggestions. So let's say the circle represents a sphere, and within this circle, which is a sphere for us, cross section, we'll consider a cone. So cone will look like a triangle, right? So when you're talking about a cross section, that is how it is going to look like. Now, what we are given here is that the radius is 5 centimeters. So that's the circle. So radius is 5 centimeters. That means these two sides are 5 centimeters. Is that clear to you? So from the center, these two sides are 5 centimeters. What dimensions of the cone of maximum volume that can be fitted into this? So as far as the volume of cone is concerned, the formula is volume is 1 by 3 pi r square h. Now for this particular cone, when we are trying to say what cone is, so it is kind of like this. If you look at three-dimensional, now you see a cone. Is it okay? So the height will be from the center of the cone, we can extend this, right? So that becomes the height. So let me call this value as y. Let me write down y here. So what we have y, and above this radius of 5. Now the radius of the cone, let this be r. So we can relate all these terms very easily now. Look at this small right triangle. Within this small right triangle, we get y square plus r square equals to 5 square, which is 25, correct? So I could write r square as 25 minus y square. Perfect. Since this is r square, we can always replace it with that. So we can now write our equation in one variable, correct, which is y for us. So we utilize the radius r to form our equation. This is very critical to understand, and that is how you should be doing when a cone and sphere is involved. So replacing r square by this, we get volume as a function of radius now as 1 over 3 pi r square is 25 minus y square. And what is height? So total height is 5 plus y, right? So let me write here, height is 5 plus y, total height, times 5 plus y. So we have the whole function in one variable. So that is the most critical step. And now we can find derivative with respect to y. So we get dv over dy equals to, you can apply the product rule, right? So we have 1 over 3 pi. Derivative of the first function is minus 2y times this, which is 5 plus y. So let me write square brackets here, plus 25 minus y square times derivative of this, which is 1, right? Okay. Bracket close. Now we need to solve this equation, and for critical value, we know this should be equal to 0. Perfect. We know this should be equal to 0. So let me equate this to 0 for critical number. So that means 1 over 3 pi is constant. This could be 0, right? So we'll just open this equation here, which is within the square brackets, equate that to 0, right? And solve for it. So minus 2y times 5 will be minus 10y. That will be minus 2y square. And here we have plus 25 minus y square equals to 0, right? So we have a quadratic equation. We can take these terms, make them positive. So we get 3y square plus 10y minus 25 equal to 0. Now, since we have this equation right here, we can solve it using quadratic formula. That is the best thing to do now, right? So let's find the quadratic formula to find the critical number. So the critical number will be y equals to minus b, which is minus 10, plus minus square root of b square, which is 100, minus 4ac, 4 times 3 times minus 25, over twice a, which is 6. Let me write 2 times 3. Okay. So that becomes your quadratic formula. We can use calculator and find this answer. So let's do it. So we have, okay, let's do it. So within the square root, 25 times this becomes plus 400, 300. So we could actually rewrite this as minus 10 plus minus 6. And here we have square root of 10 plus 25 times 4 is 100, 300. So we get 400. Is that okay? So minus, now we'll write square root of 400. So square root of 400 is 20, right? Okay. So it is minus 10 plus minus 20 over 6. Obviously, we cannot have a negative answer. So our critical number is y equals to plus 10 over 6. So that becomes the value of y as a critical number. Now what we need to show here is that the derivative, this at y indicates a maximum. Is it okay? Now that is a 0. That is one of the zeros for this given equation. The other 0 will be negative, right? The other 0 is negative. So if you want to analyze the derivative, which is this derivative, that means volume, right? We know that there are 2 zeros here. One is a negative and the other one is positive. And since we wrote this as our equation, right? Do you see that? So what is happening here is that okay, so let me write down here this value. We'll just analyze. So y value is 10 over 6 because I didn't simplify this equation a bit here. I've written though kind of like this anyway. So what you will realize here is that if you substitute a value which is less than 10 over 6, let's write down 10 divided by 6 is equal to 5 over 3, which is decimal 1.6. So this is decimal 1.6 recurring. Now if you take a value which is more than this, let us say a test point at 2 and a test point at 1, then you realize that the derivative, this expression, is positive for x equals to y equals to 1, and it is negative for y equals to 2. So you can substitute this value and figure it out. So once you do that, this is your expression, you will get that kind of a result, which indicates maximum, correct? So I'm leaving that for you to do. So what we get here is the value of y, which is going to give us the maximum volume of the sphere, which can be inscribed in a particular sphere. Maximum volume of a cone, which can be inscribed in a sphere. And now our dimensions can be of cone will be, we can calculate radius. We already know the height, which is, you can write 5 over 3 anyway, or 1.6 recurring. So we have y as 5 over 3 and radius r will be square root of 25 minus square of this will be 25 over 9 square. Is it okay? So that is the radius, which is going to be, let me write down radius as, so 9 1 over 3 will be in the denominator, right? 25 is 5, we could take this also, and 9 minus 1 will be square root of 8. Square root of 8, which could be written as 2 square root 2. So 10 over 3 square root 2. So that becomes your radius, right? Radius. And therefore the dimensions will be the radius of 10 square root 2 over 3 and height of 5 over 3. Correct? So that becomes the answer for the given question. So I hope that helps. So the idea here is to make a diagram, relate height, see how we took value of y, small triangle, and y square plus r square equals to 5 square is a critical step to understand how we can do it, right? And these are all the calculations which you can always do later. So I hope that helps. Thanks for watching. Feel free to write your comments and share your views. If you like and subscribe, that'll be great. Thank you and all the best.